Okay, so quick review of diffusion osmosis. What is diffusion? Yes. High concentration to low concentration. Everyone repeat after me, please. Diffusion is when materials move from high concentration to low concentration. Good. So that happens in just a natural law of things, right? So if I have a container of water and I put a little food coloring in, obviously as soon as I drop that food coloring, there's a lot of food coloring in that spot. I would know that because the food coloring would be really brightly colored in that spot and the rest would be clear water. But over time, that coloring will diffuse out. Why does it happen? It happens because the molecules are randomly bouncing into each other. And if you have a lot of molecules together, like in a concentrated colored area, they're going to hit together more often than they are with water. So they're going to keep bouncing apart until they are equally mixed with all of the water. That's diffusion. Similarly, if I took some perfume, I took a perfume bottle and I sprayed the perfume bottle. And so it would be a really concentrated amount of perfume right here where I sprayed it. But over time, those perfume molecules would bounce into each other, bounce into the air molecules, and eventually diffuse throughout the room, and eventually you would smell that kind of thing. Okay? So that's diffusion when any material moves from high concentration to low concentration. So what is osmosis? And that's what I'm drawing here. If you wonder why I'm drawing because we're going to talk about osmosis. And I'm using my mouse. So I have crazy mouse skills with my drawing abilities. But anyway, so what's osmosis? Gave you time there. I stalled for you to give me a really good answer. It's when water moves from high concentration to low concentration. One more time, everyone. Osmosis is when water diffuses across a semi-permeable membrane from high concentration to low concentration. Excellent. And the key there is the semi-permeable membrane because it means that the solute cannot pass through. And that's what creates the concentration gradient. For instance, if I have a cell that's in a beaker and the cell has 75% water in there and the solute, the thing dissolved in the solution of water, the salt water solution, is what percentage? 25. And the reason you know that is because that's the definition of a percent out of 100. So if 75% of the solution is H2O, then the 25% must be salt. Okay? Now, here's my cell. It's in a beaker, and here's my solution. And so my solution is going to be 60% water. And how much salt will that be? Everyone see that? And again, how? Because mental math, 100 minus 60 equals 40. So 60% water, 40% salt. Remember, this is a semi-permeable membrane. The salt cannot pass through the membrane, and so the water can. And so the water will move, like we said, from high concentration to low concentration. So one finger if you think the water will move into the cell, 2 fingers if you think the water will move out of the cell. Let's vote. Very good. The water, because there's a higher concentration here inside than outside, will move out of the cell. Okay? Now, what type of solution is this? The type of solution is determined by the amount of solute concentration. If I have a more solute concentration outside in the solution, that's what the cell is sitting in, than inside the cell, that means I have a hypertonic solution, right? When you're hyper, think of you have a lot of sugar inside you. So you can kind of equate that to a solution having a lot of solute. Could be salt, could be sugar. Anything that dissolves in a substance like water would be the solute. And so in this case, 40 is greater than 25. This is a hypertonic solution. And when you have hypertonic solution and water leaves the cell, what's going to happen to the cell? It's going to shrivel or shrink. If you have a hard time, remember, think about a balloon. If I have a balloon filled with air and I let the air out, which is similar to the water leaving, it will shrivel, right? So over time, that will happen, okay? So now I've got another situation. I've got, let's say I have 40% water. What's my solute? Everyone? 60% solute. Okay, I'm not going to label it to save a little time here, but this is the salt down here. And so I've only got a, let's see, I've got a 70% water here, which how much solute do I have? That means I have 30% solute. Okay, again, that could be salt, could be sugar, something dissolved in the substance, cannot pass through the membrane. Okay, fingers up. One finger if you think the water will move into the cell. Two fingers if you think it will move out of the cell. The movement of water. It will move into the cell. This is a hypotonic solution because the solute concentration is less than what is inside the cell. And when you have a hypotonic situation, the cell will what, everyone? The cell will swell. And I can't really draw a swell that well. That rhymes. But I'll draw this little hole because the cell will burst and the water will go out of it if it swells too much. All right? Now, the last one, I've got 50% water solution inside. What's my solute concentration? 50%. And I've got 50% water outside the cell. What's my solute concentration? Also 50%. I won't draw them this time to save time. And so this is called a isotonic solution. Isotonic means it's equal. You have equal amounts of water and solute on each side. Okay? What will happen to the cell? Will it swell? No. Will it shrivel? No. Will the cell stay the same? Sort of. That's a misleading term saying stay the same, because when you say stays the same, it means that the water stops moving. Does the water stop moving? No. If the cell membrane is permeable to water, it will keep moving. The key is that it will keep moving at the same rate. That means the rate at which those molecules are bouncing around inside the cell and moving outside the cell will happen at the same rate that the molecules bouncing outside the cell will move in. And so you draw this arrow both ways, showing an isotonic solution, and the cell state stays the same, meaning it doesn't swell or shrink. Any questions? Nice job.